Hello everyone. Today we're going to learn about the intermediate value theorem. Now, the formal definition of the intermediate value theorem states that if f of x is continuous on the closed interval a to b, and some value y is between f of a and f of b, then there exists at least one value where x is equal to c on the interval a to b, such that f of c is equal to y. So essentially what this means is that, let's say you have some function, and I'm just going to draw any function here. Say something like this. Okay, you have this value, a and b, those are your x values as indicated on the interval. Then you have some c value that is in between. That's what intermediate means, in between. You have some c value. And f of c, which would be the y value for that x value, is going to be in between f of a and f of b. Now for any theorem, your function has to be continuous. So this will always be the first thing that we would have to determine in order for us to apply the intermediate value theorem. Now IVT is also helpful if we're trying to determine if there are any x-intercepts, or in other words, any zeros. So let's say if I use the same example, right? I have a function, any function, right? Where we have f of a is over here, f of b is somewhere down here. If f of a and f of b are different signs, then that means that it must have crossed the x-axis at x is equal to c, so that we end up with f of c is equal to 0. So I kind of put here in blue what would break down our intermediate value theorem. F of x has to be continuous on the closed interval. Like I said, that's always going to be the first thing that we determine. F of a cannot equal to f of b. They do have to be different values. And then k, which is another way of calling f of c, is any real number between f of a and f of b. So the first thing that we're going to do in this lesson is determine if we can even apply the IVT. So first we're going to take a look at this graph, which is given to us by this piecewise function. Now, the first question here, we're going to break all of these questions down for different intervals so that we can check why we can't apply IVT. So the first thing you should always ask yourself is if the function is continuous. Now in this particular example in the blue box, we're checking if the function is continuous between -5 and 2. So here is -5 and here is 2, and we can see that there's that gap in the middle. So no, the function is not continuous. Now, is there a value on the interval from -5 to 2 such that f of c is equal to 2? So remember that when function notation, f of anything represents the y value. So here is 2, and I'm going to check within my function if I have any y value that is 2. And we do, which is right here. Now, does IVT guarantee a value of c such that f of c is equal to 2 on the interval -5 to 2? Why or why not? We would say no, IVT does not guarantee a value of c such that f of c is equal to 2 because f of x is not continuous. And when you're saying that it is or it isn't continuous, you always want to write down the interval. So it is not continuous on the interval -5 to 2. Now moving on to this next example where we have in red, we're going to determine if the function is continuous on the interval -1 to 5. So when I look at my graph, here is -1, 5 is somewhere way over here, but this is a line, so it will be continuous over the interval. Now, is there a value on the interval on -1 to 5 such that f of c is equal to 2? We can see that starting at -1, the line is decreasing, so it's never going to come back up to give me a y value of 2. So we would say no. Now, does IVT guarantee a value of c, again I forgot the c, such that f of c is equal to 2 on the interval -1 to 5, we would say no, we cannot use IVT. And this is because f of c equals to 2 is not between f of -1 and f of 5. Now let's break this down just a little bit more, and just to make sure that we understand why we can or can't apply IVT. So first, we always determine continuity over the interval. Then we check to make sure that f of c is equal to k also lies on the interval. And if you can answer yes to both of those questions, then IVT is applicable. Notice that in the previous slide, we answered no, then yes, yes, then no. So therefore, IVT was not applicable. So here, is there a value of x is equal to c on the interval -2 to 5 such that k is equal to 1? So here is -2, here is 5, k is equal to 1 is right here, which we do have a value, it's somewhere over here. So yes, there is a value of x is equal to c on the interval -2 to 5. However, we would say that no, IVT does not guarantee a value of x is equal to c on the interval -2 to 5. And we would say because f of x is not continuous on the interval -2 to 5. Now for this next graph, is there a value of x is equal to c on the interval 1 to 4 such that k is equal to 1? So again, we're going to come here, here's 1, and we do have a value which is right here. So in this particular case, on that interval, my function is considered to be continuous. We also have a value where k is equal to 1 that is within the interval. So yes, IVT does guarantee a value of x is equal to c on the interval 1 to 4. And we would say because f of x is continuous on the interval 1 to 4, and f of c is equal to 1 is between f of 1 and f of 4. And at this point, we can also say that the value of c is equal to 2. So every time you're solving for a value, what you're solving for is the x. Since we are given the y, we have to find the x. So now, how do we actually find the c value if we don't have a graph? So I put here some steps for you to follow as we work out this particular question. Does the intermediate value theorem guarantee a value of c on the interval 0 to 5 such that f of c is equal to 1 for the function f of x is equal to x squared plus x minus 1? So first, we're going to have to determine if the function is continuous. Now, by looking at f of x, we can see that this is a quadratic polynomial, meaning that it'll be continuous everywhere. So right away, you can go ahead and state f of x is continuous, which takes care of that first condition of the IVT. So step 1 is complete. Step 2 would be to plug in the endpoints of the interval into the function to check that the k value, which in this case is 1, is between those two y values. So first, we're going to find f of 0, which when you plug it in, you would get 0 squared plus 0 minus 1. So f of 0 is equal to -1. Then we would find f of 5. Now when we plug in 5, we get 5 squared, which is 25, plus 5 minus 1, which is 29. Now our k value, which is 1, is between -1 and 29. So right away, I know that IVT is applicable, and now we can solve for c. So when we're solving for c, we would write f of c is equal to, and now this is important, because we're solving for a different variable other than x, and I can see here from my function notation that I'm writing f of c, please make sure to replace your x values with c. So c squared plus c minus 1, and we want to make it equal to 1. From here, this is a quadratic, and we know how to solve quadratics. We have to first make it equal to 0. So we get c squared plus c minus 2 is equal to 0. And then we factor. In this case, our factors would be c plus 2, c minus 1 equals 0, giving us two c values. C is equal to negative 2, and c is equal to 1. Now this is also very important. When you're solving for c, if you have more than one answer, you have to always go back to your interval that was given, and your c value would be the one that is in that interval. Since our interval is between 0 and 5, our c value has to be 1. Negative 2 is outside of that interval, so this would be our answer. So now when it comes to justifying our answer, I put here two sentence frames, one for when it does not guarantee a value of c that you can follow, and another that does guarantee a value of c. So this first sentence frame reads, IVT does not guarantee a value of c to exist, and this would not count because, such that f of c is equal to, in this case, 1, because, and then you would have to state your reasoning. Now in our case, f of c IVT is applicable, so we would state, IVT guarantees a value of c is equal to 1 to exist such that f of c equals to 1, that's this one, because f of x is continuous, and then here we would write, instead of f of a is less than f of c is less than f of b, we would write f of a, which is 0, is less than f of c, or you can replace c with 1, is less than 5. If you are uncomfortable using the inequalities, you can just say that f of c is between f of 0 and f of 5, and that would count just as well. Now, if you do not like these sentence frames and you just don't feel comfortable knowing how to write your own response, you can always write your responses using bullet points. As long as you list all of the reasonings why we can apply IVT, whether it's in a sentence or in bullet points, it still works as your justification. So I could have my bullet points such as f of x is continuous on the interval 0 to 5, f of 0 is equal to this, f of 5 is equal to that. Then you can say f of c is equal to 1 is between f of 0 and f of 5, and then solve for c, and you would have all of your reasonings already in your response, where you would not need to write that long-winded sentence. But regardless, I'm going to be going through all of the process and giving you those responses. Let's look at another example. So this example reads, does the IVT guarantee an x-intercept over the interval 0 to 1 for the function f of x is equal to x cubed plus 2x minus 1? And if so, what is the x-intercept? Justify your answer. So remember, an x-intercept is when the y value is equal to 0. So in this particular case, f of c is equal 0. So that's what we need to know in order to continue this question. Now, for this particular question, it is calculator active, and I'm going to guide you on how to use the calculator to accurately answer this question, as well as how to use the calculator for our purposes. The majority of everything that we're going to do on the calculator can be found in the graphing section, as well as the menu that I'm going to show you. Now, for this one, I'm going to choose to answer this question using bullet points so you can see how it could be written. And then at the very end, I'll also provide the statement so that you get both options of how to justify your answer and you can decide what you prefer. All right, so the first thing that we're going to have to do while using the calculator is we want to set the window of the calculator according to the interval. So here is my calculator. So over here, you obviously turn it on. I would go to the button that says window. Now where it says x min, that is the smallest x value that you're going to see on your graph. and x max would be the largest x value you would see on the graph. And then you have the y min and y max as well. Most calculators already come with a standard viewing window, which is -10 to 10 for both the x min, x max, and the y mins and y max. Now, mine has different because I've already used this calculator, but you can just clear it. And since our interval is from, 0 to 1, I am going to set my x min at 0 and my x max as 1. Now that I've set my window, I'm going to go to my y equals menu, and this is where you input your function. So I'm going to put x. This is the button that we would use for all of our variables. This calculator tends to have issues when you try to change the variable, so we're always just going to use x. This is for exponent, and we put to the third. Then you press this arrow button so we can move out of the exponent, plus 2x minus 1. Now I can click to graph. Now, as you can see, this is the interval from 0 to 1. Our function is continuous, so I'm going to go ahead and already write that out. F of x is continuous on the interval 0 to 1. Next, we're going to find our function values. So I need to know what is f of 0 and f of 1. So in order to find function values, we're going to click on second, and then right here, the trace button right above in blue it says calc. So the second button activates that blue. So when I press this button, it's going to take me to the calculate menu. Now, when you're looking for a function value, that is the very first option where it says value. So I can click enter. And then it'll say x equals, and you put the x value that you want to find the y value for. So I'm going to click on 0, enter, and we get a y value of -1. From there, I don't need to go back into the calc menu to find f of 1. I can just go ahead and type in 1 and see it already says x is equal to 1. I press enter, and it gives me that y value of 2. Now here, since one value is negative, the other value is positive, that means it crossed the x-axis, and so we do have an x-intercept. And I mean, when you look at the graph, you can see that we have an x-intercept right here. It's when it changes from negative to positive. So I can now follow this up and write f of c is equal to 0 is between f of 0 and f of 1. Or you could also have written f of 0 is less than f of c is less than f of 1. And this would mean the same thing. You don't need to write both. But just in case, if you do like inequalities, you can write it that way. All right, so now this right here lets me know that IVT is applicable. So I can just state that right now. IVT is applicable. And now I can find my C value. So since we're looking for an x-intercept, the calculator knows how to do that for us. If I go back to my calc menu, you'll see option 2, it says 0. This is the equivalent to an x-intercept because x-intercepts occur when your value is 0. So we're going to put 2. And it's going to ask you for the left bound. So you're going to use these buttons here in order to move that little blinking X. And I'm going to move this to the left of my x-intercept. All right, this is to the left of it. It doesn't have to go all the way to the left. It could be closer. It does not matter as long as it is below the x-axis. I can press enter. It's going to ask me for right bound. You're going to go to the right side of your x-intercept. Press enter, and then it's going to ask to guess, and you say sure, why not? Press enter, and here it gives you the 0. This is your C value. Now when you're writing down your C value, you're always going to truncate your answer. Truncate means to not round. You're just going to cut it off, and we always want at least 4 decimal points. So we have our C value is at 0.4533. So right here, by writing all of this out in bullet points, I don't need to do any further justifications because everything has been justified here already. But if you did want to write a statement, because, you know, it's better safe than sorry, you can say IVT guarantees a value of C is equal to 0.4533 such that f of C is equal to 0 because f of x is continuous on the interval 0 to 1 and f of C is between f of 0 and f of 1. So whichever way you choose to write your answer is totally acceptable. Okay, so now let's try this again. We're going to continue practicing with our calculators. Although A can be done without a calculator, we're going to go ahead and practice with it. So our first step would be to adjust our windows. So now our window is going to be from -1 to 3. So -1, enter 3. I'm going to go to my y equals. I'm going to clear this out. Now, when you have a rational function, the calculator doesn't know what to do unless you tell it what to do. So if you have a numerator and a denominator, we're going to put the entire numerator in parentheses so it knows that we're going to divide all of that by the entire denominator. So see, I put x minus 3 inside parentheses, the division symbol, because these calculators don't know how to do a fraction. So remember, fractions are division, so we use the division symbol. Then I'm going to put the entire denominator also in parentheses, which is x plus 2. Close it, and then we can press enter, and now we're ready to graph. Now from this graph, we can definitely see that it is continuous. So we can state f of x is continuous on the interval -1 to 3. Next, we're going to find our endpoints. So I need f of -1 as well as f of 3. So on the calculator, remember when we're finding function values, that is in the second calc menu. I press enter for value. First one is -1. And we get that y value is -4. Next, we're going to plug in 3, press enter, and we get a y value of 0. Now, if I can continue, I would, but I see that f of c is equal to 2 over 3, and 2 over 3 is greater than 0. So it is not between this interval because f of -1 is a -4. And if you look at the graph, you can see that it never goes above the x-axis at this point, so it's not going to be a positive 2 over 3. So our justification for this, I would write IVT is not applicable because f of c, which is equal to 2 over 3, is not between f of -1 and f of 3. Moving on to the next example, we have f of x is equal to 2 raised to the -x plus 3 minus 1 on the interval 0 to 5, and we want to find for f of c is equal to 0. So I'm going to, again, go ahead and adjust my window. Now it's from 0 to 5. I'm going to go to my y equals menu, and I'm going to type in my function. So I'm going to delete this one. I'm going to type in 2 raised. Now this particular calculator simulator, you already see the exponent. But if you're using an older model, it doesn't. When you put the little symbol, that's what you actually see written out here. And then you'll have to open a parentheses to put the entire exponent, which I'm going to do anyway in case you have that model. So I'm going to open a parentheses. I'm going to put my exponent, which is negative x plus 3. I'm going to close the parentheses, so that way that's my entire exponent. I'm going to move over to the side to move from there, and I'll put minus 1. Now, I forgot to mention this earlier, but if you ever need to input a negative, not a minus, you need to use this symbol down here. Otherwise, if you use the minus symbol, it'll tell you that there is a syntax error. So that's how you would know that you inputted the wrong symbol and to go back and fix it. All right, so now we're ready to graph. And we do see that f of c is equal to 0 somewhere right here, because that is our x-intercept. Our function is also continuous over this interval, so I already know that IVT is applicable, but we're still going to go through our process here. So the first thing I would state is f of x is continuous on the interval 0 to 5. Next, I'm going to find f of 0 and f of 5. So I'm going to go to my calculator here, second calc, selected value, 0 for the first one, and we get 7. Now I'm going to go ahead and do 5, enter, and we get negative 0.75. You see 0 is between 0 and negative 0.75, so automatically I can state IVT is applicable. And I can also give my reasoning already, because f of c is equal to 0 is between f of 0 and f of 5. Now I can go ahead and solve for c, which is an x-intercept. So we're going to go ahead and go to second calc, select 0. So I can either scroll down with the arrow, I can just press the number 2. It's going to ask me for the left bound. So again, I'm going to drag my little blinking x over to the left of my x-intercept. Press enter. And now we're going to drag it to the right of my x-intercept. Press enter. Sure, give it a guess. And it gives you that c is equal to 3. And then we're done. Let's move on to another example. Now these, in every calculus type of concept, we're going to learn various ways of how these concepts could be represented graphically, which we did at the beginning, algebraically, which we just finished, and now there's also charts along with some kind of verbal description. So we're going to look at that together. This one says, a car travels on a straight track. During the time interval where t is between 0 and 60 seconds, the car's velocity v, measured in feet per second, is a continuous function. So already it tells us that our function is continuous, and therefore I can proceed with my theorem. The table below shows selected values of the function. And so here in the table we can see that this first row is all of our seconds, and the second row are the velocities. For t is between 0 and 60, must there be a time t when v of t is equal to negative 5, and then we're going to justify. So this is like our f of c. Okay, and we want to see where it lies between, what two velocity values, right, would include negative 5 in the middle. So when I look here, if I were to choose this interval from 0 to 15, negative 5 is not between it because it goes from negative 20 to negative 30. Then over here, from negative 30 to negative 20, negative 5 is not in the middle. And if I continue, I see that right here, negative 10 to 0, negative 5 would be right in between of negative 10 and 0. So this question is asking for, must there be a time? So remember that we're looking for the t values. which are these right here. So in order to answer this question, I already know IVT would guarantee a value of t time when v of t is equal to -5. Now it's not asking us what that t value is because it's impossible to figure that out without any more information. It's just asking, must there be a time? So we would say, yeah, there is a time. So remember, we still have to go through our theorem and make sure that we include all of those properties that encompass the theorem. So I would say, since v of t is continuous, because remember, that's always our first condition, is our function continuous. And v of 35, which is equal to -10, and v of 50, which is equal to 0, IVT guarantees a value of t such that v of t is equal to -5 on the interval 35 to 50. And that would be our answer, is between 35 and 50. Now, it doesn't mean that your response has to be written exactly like this, but as long as it has the information that v of t is continuous and that v of t is equal to -5 is between v of 35 and v of 50, your answer would be sufficient. Let's go on now to our last examples. All right, so this first one, we're going to use this graph to answer the following questions. Is there a value of c on the interval -3 to 4 such that f of c is equal to 1? So here is -3, here is 4, f of c is equal to 1 right here. So yeah, it does. Now, does IVT guarantee a value of c such that f of c is equal to 1 on the interval -3 to 4? Why or why not? Here, no. IVT does not guarantee a value of c, and that is because f of x is not continuous on the interval. Okay? Now let's take a look at this example. Now this one in particular, we're going to go ahead and work it out by hand, just so you can get some practice. Okay? So this says, can you show for the function f of x is equal to x over x minus 3 that f of c is equal to -1 over 2 on the closed interval -3 to 2? If so, find the value of c and justify your answer. Now, since I'm not going to use the calculator, I'd have to be familiar with when rational functions are discontinuous. All rational functions are not continuous when the denominator is equal to 0. Because if the denominator is equal to 0, that means that we have a vertical asymptote. So for this particular question, the denominator is equal to 0 when x is equal to 3. And that is where we have a vertical asymptote. However, when I look at my interval, x is equal to 3 is outside of this interval. So our function f of x is continuous on that interval. So you can be specific and you can say f of x is continuous on the interval -3 to 2. And you can also state that you understand that it's discontinuous, but that it lies outside the interval. So you can say is continuous on this interval because x is equal to 3 is where f of x has a vertical asymptote, which is outside the interval. Now we need to find our function values. So we're going to find f of -3 and f of 2. When I plug in -3, I would get -3 over -3 minus 3, which is -6. And that gives me a positive 1 over 2. For f of 2, I get 2 over negative 1, which is equal to negative 2. At this point, I can see that f of c, which is equal to negative 1/2, is on that interval. So I can already go ahead and state IVT is applicable because f of c is between f of negative 3 and f of 2. And now the last part would be to actually find that c value. So just give me a second. I'm just going to shrink this a little bit. If I can, that would be lovely. Here we go. All right, just so that we can have some space here to write out our c value. Just going to move this over here for now. Okay, so now when we're solving for c, remember that we are finding f of c, which is equal to c over c minus 3, and I'm going to make it equal to negative 1 over 2. When you're solving this, you can cross multiply. Remember, when a fraction is negative, you can assign that negative to either go with the numerator or the denominator. By default, I always put the negative in the numerator. So now this would give me the equation 2 times c, which is 2c, is equal to, then negative 1 times c minus 3 would make it negative c plus 3. And now I can solve for c. So I'm going to add c to both sides, and I get 3c is equal to 3. And then we divide the 3. So c is equal to 1. And see that c is equal to 1 is within my interval negative 3 to 2. For this next one, we're going to go ahead and use the calculator. Can you show for g of x is equal to 1 over 2 raised to the 2 minus x plus 3 that g of c is equal to 7 on the closed interval 1 to 5? And if so, find the value of c and justify your answer. So just like before, we're going to go ahead and determine if our function is continuous. We're going to graph it with our interval. So I'm going to go to my window, turn it on, window, and I'm going to my x min and my x max. So 1 to 5, that's already 5. I'm going to go to my y equals menu so I can input my new function. I'm going to put a parentheses, and instead of 1/2, remember it doesn't know how to do those fractions, so we can just do 1 divided by 2, close parentheses. I'm going to put this in my exponent, the 2 minus x. Remember, if you're using the physical calculator, that does not do this automatically, where if you can see the exponent, you have to open a parentheses and put 2 minus x and then close it. Move off to the side, put plus 3, and now I'm going to go ahead and graph. As we can see, the graph is continuous, so I can go ahead and state g of x is continuous on the interval 1 to 5. Next, I'm going to find g of 1 and g of 5. So on my calculator here, I'm going to go to my second calc menu, option 1. I'm going to first find the function value for when x is 1, which is 3.5. Now I'm going to find for my function value when x is 5, which is 11. We can see that 7 is between 3.5 and 11, so we can state IVT is applicable because g of c is between g of 1 and g of 5. Now we need to actually find the value of c. So we're going to set up our equation here just so you can see what I'm going to do, which is g of c is equal to 1 over 2 raised to the 2 minus c plus 3, and we make it equal to 7. Now the calculator doesn't know how to find a particular x value for when y is anything other than 0. Those are our x-intercepts. So whenever you have a scenario like this, we need to first make it equal to 0, and then we can go ahead and graph. So we're going to subtract this 7, and our function will now read 1 over 2 raised to the 2 minus c minus 4 is equal to 0. This is what I'm going to graph. So I'm going to come here to my calculator. I'm going to go to my y equals, and we can just reuse this function. I'm just going to go all the way to the end. And instead of plus 3, I'm going to replace that with minus 4. Now I'm going to graph. So what I'm looking for here, since this is for when your function is equal to 0, I'm looking for my x-intercept, which is right here. So we can go to the second calc menu. I'm going to go to option 2. Let's go to the left side of the x-intercept, which I was already on the left. We go to the right. Go ahead and guess. And we get that x is equal to 0. But remember, on your paper, you have to write, because we were solving for c, c is equal to 4. And that's how you use the intermediate value theorem with both calculator and without.